Hey, how's it going, everybody? Today we are going to talk about sums, aka series, and sigma notation. So you're going to do a couple more sums today, except we're not going to take advantage of any fancy formulas, except for maybe the very last problem, but it's fine. You don't need them. We're going to just do sums the hard way. This lesson is more about you being able to understand the sigma notation than it is about the sums themselves. So let's go just review sigma notation really quick. So here is the general way that you are going to write sigma notation, and you're actually not going to have to write this. This is going to be given to you. But let's talk about what you are looking at here so that you kind of understand how to read this. Okay. I is called the index, and it is the thing that is going to be changing as you do the sum. Okay, and it'll make more sense in a second once I give you this concrete example over here. But for now, just realize that this thing is called an index. Okay. This is saying we're going to add up all of the terms as I goes from m to n. So m is your lower bound, and you can probably guess n is your upper bound. Whoops. And these two numbers are just telling you where to start and where to stop. You can see it right here. When we say AI, we mean elements of the arithmetic sequence or terms in the list. And we mean the terms that start at m and end at n. So let's go look at this concrete example. So we are seeing our index here is I. So this variable is the one where we're going to be plugging in different numbers. And the numbers we're going to plug in are 3 through 6. So we're going to start at 3, end at 6, and then all the different terms we get by plugging in those 4 different numbers, we'll add those terms together. Okay. On your homework, they're going to give you this thing. Just realize that this is actually the explicit notation for either the arithmetic or geometric sequence. This is the formula that you're going to be using. If you write out the list of terms, you're going to really quickly see that they turn into an arithmetic or a geometric sequence. All right, sorry. Ooh, got ghosts in my... Wait. I might have ghosts. All right. If I die in the middle of this video, you know who to call. Ghostbusters! All right, cool. Just so you know. All right, so let's do this first example. So they want us to take this sequence, whatever sequence is described by this rule, and they want us to add up the 3rd, 4th, 5th, and 6th terms in that sequence. So the first thing we're going to do is we're going to plug in 3 into I. So we're going to have 5 minus 2 times 3. We're going to take this thing, and then we're going to add it to the next one. So we plugged in 3, now you plug in 4. So this is going to be 5 minus 2 times 4. And then you just repeat this until you get to your upper bound. So then we're going to have 5 minus 2 times 5, close parenthesis, plus 5 minus 2 times 6. Okay. And this is how they want you to do your homework. They want you to just simplify all 4 of these terms and then add them up. So if we simplify this first one, negative 2 times 3 is negative 6. So 5 minus 6 is negative 1, plus 2 times 4 is 8. So 5 minus 8 is negative 3, plus 2 times 5 is 10. 5 minus 10 is negative 5. And then 2 times 6 is 12. 5 minus 12 is negative 7. Okay. So we could write it this way. Because it's a series, we're adding, but because we're adding negative numbers, you might even want to simplify this to negative 1 minus 3 minus 5 minus 7. These are actually the terms in the sequence. So you can see the trend is just subtract 2 every time. That's not a coincidence. That's from that minus 2 right there. So now we go ahead and just subtract all these or add these negative numbers together, and we get negative 16. And then you're done. That's it. It's easy as pie, easy as cake. Oh no, you guys, I'm explaining this too quick. Your video might not be 27 minutes today. I know, what are you gonna do? Let's do another example. Ooh, this one looks a little scarier just because we have an exponent for the index now. But I think you guys are gonna be okay. So let's set this up. We're gonna have 4 plus the 5th term plus the 6th term plus the 7th term. So we'll fill these out. So this is 3 times negative 2 to the 4th, 3 times negative 2 to the 5th, 3 times negative 2 to the 6th, and then finally 3 times negative 2 to the 7th. All right, unfortunately, I did not do these ahead of time. But Barton, you're wasting our time. You're making us wait too long. It's all right. It's good for your soul. All right, so we have 2 to the 4th, negative 2 to the 4th, 2, 4, 8, 16. So this could be 3 times 16 plus 3. Negative 2 times 16 is negative 32 plus 3 times positive 64 plus 3 times negative 128. Okay, now you're going to have to excuse me, but I'm going to need to go ahead and type this into a calculator. So 3 times 16 plus 3 times negative 32 plus 3 times 64 plus 3 times negative 128. When we do this sum, we get negative 240. You could go through and simplify these, but it's probably just as easy for you to type all of this stuff into the calculator. Just make sure that these negatives, you're putting them in parentheses or you're putting a time symbol in between them. Otherwise, you might accidentally do like 3 minus 32 in your calculator, and then you're going to get the wrong answer, and you're going to get mad, and you're going, oh, Barton, you taught me wrong, it doesn't work, and you're going to get all whiny. No, I'm just kidding. You guys would never whine. All right, so that's how you're going to do your homework. It's pretty straightforward, but you know I can't let this video be 7 minutes and 22 seconds long. So we have a tough big kid example. All right, so what makes this a big kid example is these two numbers are really far apart. Are you going to want to add up all of these terms? You didn't want to add up 4 terms. You're definitely not going to want to add up 34 terms. Definitely not. So here's how we're going to do this. We're going to think a little hard. We're going to apply what we've learned in previous lessons, and then we're going to solve this in an intelligent way. I don't think that this is on your homework. And I shouldn't tell you that because immediately 6 kids just closed the video. But this is an extra bonus question, right? This is just, you're going to need to know this someday if you go to college and study math or science, of course. So let's investigate. Let's go ahead and start by plugging in 4 and just see what happens, right? So we have 4 plus 10 times 4. What is that? That's 44, right? 40 plus 4 is 44. All right, let's plug in another one. Plus 4 times 10, plus 10 times 5. So that's 54. And right away, you can kind of see what the pattern is going to be, right? This could be 4 plus 10 times 6. So this could be plus 64. Okay. So now let's look at this thing. If I just gave you the list, 44, 54, 64, ... and I said, add up all these terms, you could definitely do that. That's what yesterday's lesson was. The tricky thing here is counting which or how many terms there are. And you're going to go, well, Barton, just do 37 minus 4. There's 33 of them. This is wrong. You have to be really careful when you do this because that's the difference between these. That's how many steps it takes to get from here to here. You're not counting the one you start at though when you do that. So there are actually going to be 34 terms. And the way I think about that is this is term 4, this is term 5, this is term 6. But we don't want to start at 4. We're going to pretend this is term 1. All right, then this is term 2, then this is term 3. How far apart are these numbers? Minus 3, minus 3, minus 3. So you want to do minus 3 here, not minus 4. That way you actually include that first term. So it's going to be 34 terms. All right, so we know from yesterday's lesson that we have a formula for adding up arithmetic sequences, right? That formula is n over 2 times a1 plus an. We know n. We just figured it out through a little bit of logic and reasoning and thinking a little hard. N is going to be 34 because there are going to be 34 numbers in this list. A1, the first number in our list is 44. Okay, now we just need to figure out what's that last number. This is actually pretty easy because they give us this nice formula. We're just going to plug in the 37 because that'll be the number we end on, right? So 4 plus 10 times 37. This is 370 plus 4. So A34, which is actually the 37th term, is 374. Now we can plug these three numbers into that formula we learned yesterday to get the sum of these terms without having to actually write out all 34 of them and struggle through it and get really mad at our math teacher. But again, this is extra. It's not going to be on your homework, I don't think. So we have 34 over 2 times 44 plus 374. So this simplifies to 17. Let's see, 4 plus 4 is 8, 418. And then you grab your calculator, put that thing in the calculator, and ta-da, we don't hate our math teacher anymore because he's a really nice guy who just wants the best for us in life. And we find out that the answer is 7,106. Okay. If you made it the extra 5 minutes through the lesson, I commend you. Thank you for watching this bonus question, even though it probably wasn't 100% necessary. If I had really thought this through about rewarding you, there would be like a sweet picture here. But there's not. I don't know. What do you guys know how to draw? All right, I'll see you in the next video. Don't forget to like and subscribe.